Okay, so by looking at the wave function, we can inspect the wave function. We can tell some things immediately. So one, this term before the trigonometric function here dictates the amplitude. That is the distance between, for instance, the x-axis, right, and the height of the peak of this sine wave. Okay. And here, right, this tells us about period of the wave, okay? And so, and again, this is the same definition of period that we discussed in an earlier video, all right? And so the period, right, for any sine function, sine with the form of sine of b times x, right, the period is tau is equal to 2 pi over b, okay? So b in this case, right, is this whole term here, all right? So that's going to be equal, so the period, right, for the wave function for the one-dimensional particle in the box, right, is going to be 2 pi over n pi divided by a, right? So we have 2 pi times a over n pi. The pi cancels out. And so the period for the wave function of any integer n is going to be 2 times a over n. Right? So just to simplify that, make that a little bit simpler to see. Okay, so that'll allow us to see, draw or sketch pretty quickly what the wave function should look like. Okay. So for instance, let's say we want to look at n equals 1, the wave function for n equals 1. Okay, so we have the amplitude, right, is going to be, the value of it is going to be at 2 pi,